Okay, today I'm gonna talk about how we can write applications today and what I believe will be the standard in the future, close future. So just a few words about me. My name is Mariusz Nowak. I'm from Warsaw, as Bertrand said. I'm really devoted to the open web. I work as a JavaScript programmer. I mean, JavaScript is my main programming language since 5 years, and this month I started to work with Unity on a very exciting project. So, and I host a lot of stuff that I do on GitHub, and I publish some news on Twitter. So if you're into the subject, you visit my pages. I think there's a lot of interesting stuff over there. Yes, so today I'm going to talk about the application which is from ground up written in JavaScript, both server and client side, full stack HTML5 application. Browsers 10 years, I mean, landscape changed very much in the last 10 years. I mean, today's browsers are much more capable. We have also JavaScript on the server side. But what's important in today's browser, we can do things that we used to do on a server. So this also gives us much more possibilities, and we can do much more performant applications. So the generic conclusion is that the less you do on a server, the more clients you can serve. Yeah, for my previous client at the beginning of this year, I delivered full stack HTML5 application, and I'm gonna demonstrate it right now. And then my previous client is Roche, so probably you recognize because it's a Swiss origin company. The system was a patient registry system, which was dedicated for the countries in Asia, Africa. It was meant to be easy to install. It was meant to be also networked application, but not dependent on network. So one of the obvious choices for that was HTML5, and this is how we developed it. So I'm gonna just do a short demo how it looks and works. So yeah, so this is this application. It looks as pretty basic web application, yes. Typical patient registry system. If you look at the source code, it's single page app. So basically, it's a source code. The whole application is basically this file. This is just the a Google Chrome frame logic and just basic containers for HTML. What I will do now, for example, I will just shut down the server that serves this application. Yeah, it's done. But application works as it works. So imagine you have some shitty connection on whatever, some African steppes, you can still operate it. So yeah, so for example, now I'm gonna add some new patient, whatever. I've gone too fast. Will be probably 10th John Smith in this application. Okay. So it's over here in the list as well. Yeah, we have actually two John Smiths. I'm gonna run the server again because I want to show also other thing, how this application works with the across the instances, because doctor may use many devices. Technically, even two users in different places may use this application at once. However, for this application, it's not that real use case. So I'm gonna also open it in Firefox. Yeah, I'm gonna log in with exactly the same user. Actually, I mean, it's not that surprising, but actually this patient that I just created is already here. However, if I, for example, now change his surname to something else, let's say I'm gonna choose now a very common Polish name. If you see in Firefox, it immediately updated. So when clients are online, all data is synchronized immediately. It maintains just socket connections with the server very light, so only needed data is communicated. And it works on every level. If I sort now by the age, I'm gonna go back to here. What's the server? For example, I'm gonna make this patient a bit older. How much? About 5 years, let's say. So save. Yeah, see the Mr. Kowalski now just went down up there. If I filter it, yeah, Kowalski, Kowalska, and let's say I'm gonna change the surname of the Tony Tracy Craft to the. You see, it appears also immediately in other place. So this is like regular application, but works very different way, and really it doesn't need much resources or connection with the server to work like that. So I think it's kind of impressive. So now I'm gonna talk more a bit about the like internals, how it was built. Also, the other thing I want to show that, for example, if you open many tabs, yeah, you see there I've opened many tabs, but for example, if in one browser you log out in one tab, all the other tabs are also logged out. So it's like everything's like well communicated. So I'm gonna go back to my presentation. Yes, so I'm gonna talk about the architecture because I think it's quite interesting for you. Do you work with a single page apps? Like Backbone or something? It's not. It doesn't use Backbone at all. But let's say some of the idea is pretty same. Yeah. Yeah. So in this application, actually, it's we used like Node.js modules. I mean Node.js modules, Node.js style modules. That's what I mean. Not that modules taken from Node.js. So technically, it's like common JS modules, bind it into one file. So basically, it's a client-side code statistics. So it's a over 300 modules binded into one file. 60% of these modules also work on server side. So it's also the good example of sharing the code between server and client. Yeah, when that file concatenated weighs nearly half megabyte, so it might seem quite a lot, but it's like with all the comments, with all the spaces, it's just as it was written source code. When you minify it, it's 220 kilobytes. When you keep it, it's just 60 kilobytes. So basically, and what's important, I forgot to add, this application has JavaScript, have a database engine written in JavaScript, all the templates engine, everything sits in here. So it's everything with this application code to weight 60 kilobytes when transferred to the client. So, you know, it's less than average picture on Facebook in its whole application. Of course, a part of static files like CSS or images. Yeah, so how is it built? Like now, module per module. So as I said, code is organized with common JS modules. So basically, there's a import-export logic if you work with the other languages like Python. I'm not sure exactly how it's in Ruby, but it's pretty similar into the Python's system that you do requires, you export stuff that you want to export. And for the client side, I came up with a tool that bundles those modules into one file, so it can be executed in the browser, because browser doesn't like support CommonJS natively. There will be Harmony modules, but it's a bit distant future, and also Harmony modules is pretty much the same. It's just dedicated syntax, so it will be quite easy to port it to Harmony modules when it will be ready. Yeah, so maybe I moved too fast, but if you see, this is those files concatenated, and just down below I just cut it off. It's a logic that, for example, here is which program needs to run first. So this logic, which is commented out, runs this and passes requires, which then passes the other modules. That's how it works. Internal. If you know how Node.js modules works, it should be quite obvious, yes. But if you don't, then probably it's also speech for another. Can be whole speech about really module systems. I don't want to do too much about this now. Yeah, last year on Warsaw meetup, I've done some presentation about JavaScript modules. I mean, the way I believe is to do it best. So Node.js style modules, so you can use it without any boilerplate on both server and client side. So all my reasoning and example of this and how it works is there's a link. This subject is a link. I will post the link to that presentation later on Twitter. So if you're interested, you can see those slides later. Yeah, data storage. This is like the most important thing because as you saw, everything is changing live, but what database engine manages this? Because when we are cut off from the server, how this data is handled. So there's basically database engine written in JavaScript. Pretty simple, but working very well. Yeah, and basically persistent layer, like where we need to save physically data. On the server side, we use MongoDB. On the client side, we use local storage, but it's just about saving hashes, JSON object, because all the like database engine, I mean, filtering, searching, relations is written in JavaScript. So this data is polluted to this database engine, and then it works. It's the same engine that is used on server side and on client side. Yeah, so what I said, simple key value pairs are served physically, MongoDB and local storage on the client. Yeah, data manipulation, so this is about that event and database engine in JavaScript that I just mentioned. This is just example how the namespace is, no, this is just example, yeah, this is an example how the namespaces are created in that database engine. Sorry. Doctor, patient, an example of this application, visit. You provide a schema, fields, provide the type. This is just like a simplified example, of course. I just wanted to show how it works internally. We use like ECMAScript 5 features, so we use enumerable properties for the actual objects that are important from scope application and not enumerable properties for meta properties. So for example, if you use object keys on created doctor, you will see all its like database properties like name, surname, etc. But there are also hidden properties like ID, which is a system ID, created date, updated date. So this allows us to easily use those objects with like common JavaScript functions, because common JavaScript functions just work on enumerable properties. Yes, so namespace, database itself, I mean database object itself, namespace is also like collection. It's unordered collection, it's like hash in JavaScript, where each enumerable property is an instance of some doctor. If it's namespace of a doctor, if it's database, then it may be an instance of anything. Yeah. Relations, this is like a kind of thing to go the other way. For example, we have a patient which is assigned to the doctor, so there's a doctor field on the patient, but at some point in the application we want to know which patient belongs to given doctor. So database tracks such relations not explicitly stated in the objects. So you can easily with a specific method get to the like patients of a doctor. Yeah, when you output data, we usually want to output in like a specific order. So out of this unordered collection, we can like get list, which is basically simple array in JavaScript, but this is like live array. So if anything changes in our database, this array is changed and also emits events. So on that basis, our tables update. So when I shown that arrays table is resorted, filter is filter will be other example, but like filter is extended by the object, it works on those events. Yeah, so this is the filter example. I mean, filter are also unordered, but again from the filters we can get ordered lists, and everything is binded with events and live. Yeah, so that was the like this is like the core, basically, because it's about data. So synchronization is basically made with simple, I mean, just simple messages to the socket IO, just simple updates. There's no REST involved. The common question is that you may have is about conflicts. Is if in offline in two instances we change the same object, then we get off online which one really wins. So currently we just solve it very simply that that application that latest update wins. So there's no conflict resolution, latest update wins, and it works really well. I mean, in scope of this application, this is basically patient is managed by one doctor. So usually that change, conflicting change, will be made for one person. So usually the later change will be the one that we are after. So there's no like conflict resolution mechanism exposed to the user, and it was no issue so far. Templates, yeah, this has also been done not that conventional way, because templates are pure JavaScript, and it's like object-oriented approach. Like common approach like derives from the server side tradition that we make HTML string and then we do inner HTML into the DOM. But like we are on client side already, so here I decided to work with objects directly. I don't create HTML. We just create the DOM objects directly. So this is the example how it's written, and it's also like plain JavaScript. So as simple as you can structure HTML with plain JavaScript. And it also gives much more possibilities because we don't exchange objects. When you do the strings, you need to like exchange object after you update. So you need to clean their event listeners, etc. And here we update the actual object, update the text nodes, the attributes. We don't really remove those objects. So yeah, it allows like I think better separative concern. Like for example, when we are building a select, we can build a whole select with whole options and later decide which one should be selected. We don't need to do it like in line everything. Yeah, this engine is also on GitHub. So if you find this approach interesting, try it. Yeah, views and routing, because like page changes. So yeah, single page application. However, down below there are regular links and URLs. So technically, it was made that way to be able to easily port it as a application from the server side, serving static pages. So in the client that supports. Like this architecture, links are hijacked and view changes are invoked. So all the clicks to the hrefs are hijacked, and then internal logic changes the elements that needs to be changed. Yeah, browser history is handled with HTML5 history. So views are defined by describing the differences. I found it as like most natural because when you look at the web page, like home website, you have a header, footer, some sidebar, content bar, and you go to some other place. Usually just some part of changes, not everything. So this is the way down. For example, if you go from home to profile, header stays the same, the content changes, and just some tab obtains new class. So this is how in each template you just describe the differences, and this engine knows how to get there and go back from there. So for example, when there are, for example, described differences for add visit, and then from add visit I want to go directly to the visits, the engine calculates his way back here, like that way. So, and then calculates which object needs to be HTML object needs to be updated. So only stuff that you see is updated is really updated, the others stay intact. So it's also quite performant. Yeah, this is just a few words about some other more low-level modules that are used here. Socket.io, it's I think very popular. Have you used Socket.io? Yeah. So socket connections with between client and the server. So this application might be not best example for Socket.io because Socket.io is very about real time, so stuff that we need to constantly update. However, with this application, it's also good to know when we are online and offline. So technically, I could use Ajax and probably some server-side events, but the Socket.io makes a really good solution. And so it's very light, like Socket connection is very light, backend is Node, it works really well. Yeah, formidable for the asynchronous file uploads on the server side. It's a really great tool by Felix, I can't say his surname. Yeah, Geisenhoff. It's used, but this module was built for the transloaded, such a website, so it's used very well on production, and it just works. Yeah, Node Mailer for mails. Yeah, JSLint. MongoDB driver. Yeah, test suite. All low-level modules here have tests. Just application itself doesn't have tests. We were supposed to like change it, but I didn't manage actually. But anyway, like the most important stuff for the tests are that low level, like database engine, this stuff. Because also this project was lucky enough to have like testers assigned to it, so all the like let's say UX logic, client-side logic bugs were quickly picked up by testers, by people. And yeah, about some more level modules, few words. Yeah, this is something like, do you use underscore? Not much. Yes. Yeah, so ES5X is actually something like modular underscore. It's like functions that extend the standard. But ES5X is like very modular. Each function is separate module, so we decide explicitly which modules we should use. And also in ES5X, most those functions are defined as methods, which also could be used as functions. So like in application dedicated logic, we actually extended the native prototypes because we didn't mind. But low-level modules doesn't use extended prototype version, but still they're using the same function. So it's also like kind of a safe. Deferred is for asynchronous programming. Have you programmed with Node? Like, have you some troubles with asynchronous programming, callbacks, hell, or something like this? Yeah. So, and do you know promise concept? Promises. Yeah. So I think this is the best solution. Like, I wouldn't advise to use it just for a few callbacks. If you just have few asynchronous call, leave it the way it is. It's the best way. But if you really need to set up some complicated flow, this is the best thing, promises. So, and I'm really happy how this tool turned out. I don't see really any limits with this. So, of course, as with asynchronous programming, it also takes time to really get it. But if you have problem with asynchronous programming and really would like to solve it, I advise you devote some time and look at it, because it really solves the issue. Basic event emitter. I just need a cross-environment event emitter that works both in Node and client side, so it's something obvious. Yeah, browser supports, I forgot to add it, but we just supported the modern browsers. That was the case. Actually, it was like about Firefox 7 at the time. But it works also like in Chrome, of course, Safari. Yeah, it's ECMAScript 5 application. It's important. IE8, for example, doesn't support ECMAScript 5, so it's impossible to run it on IE8. It would be possible to run it on IE9, but without offline, because it doesn't support offline and no history. So we'll need to decide to do those hash URLs, which is controversial, because then we have two different URLs for our application. We need to support this. So I wouldn't support IE9 either in this kind of applications. IE10 would be good, I believe. So this is a popular question, what about, because we still, well, it's not 2020 yet. Yes, we still need to support some engines sometimes, older. So with this architecture, it's JavaScript, it's Node.js. We can it's written that way that with small adjustment you can basically serve static pages. So you can build it that way so that static pages are served to the older browser and the new browsers work as applications. Yeah, so and this trend is growing. It's like one of the examples of the applications, but there are many like frameworks emerging now. None of these frameworks is used here because sometimes people get confused and think that it was Meteor or something. No, I just want to show that this is the framework which share some concepts that I used when building this application. So yeah, Meteor is quite popular because it allowed us live changes between browsers, machines. Spines also share the idea of the not sharing state with the server, that when you change something on the client, it immediately updates. You don't wait for the server to confirm. You just send the data to the server. Yeah, Ember is famous from the data binding stuff, that when you change something in database, it immediately changes in your view. So it's worth to look at this stuff because it's really, it will grow, and I believe that in 5–10 years, that way application will work. Do you have any questions?
How long did it take to create the application? For work in the project?
Actually, at the beginning, so like the core application, I was working just by myself. Later, when it was like already working, we need to add like some user functionalities. Rather, I had some people to help. How long did it take? Now it's even hard for me to say, but it started, I think, about April, May last year, and by the end of the last year, I had like the first version, not extended by some functionalities, ready. So what I show you could be shown the last year, so 8 months probably. So it was like most of the stuff was built from the scratch.
Are parts of the application that you could put as libraries or export?
Yeah, I mean most of it. Actually, low-level modules. Yeah, this is important questions. It's very well modularized. I mean, each thing that I talk separately is separate module. There's no like mix and I just show I don't know what. So low-level modules like those different ES5X, DOM.js, which is like template site, is already published on GitHub. You can use it. The other stuff, we will continue to evolve this architecture with UNCTAD, and everything will be open source. And finally, I want to wrap it in some kind of a framework so we can really quickly develop such applications. So just follow me on GitHub and Twitter, and you'll get all the news as they're coming about this. Yeah.
How many users are there for this application?
Sorry?
How many users?
Roche wants to install in the clinics in hospitals. How many clinics is installed? When I left Roche, it was just in one in Switzerland. I'm not sure really how many users were using it. It's probably a more political thing about this, because they also want to have some benefit from giving away this application. So, you know, it's a kind of beyond me. I can't say now. I don't know of any like real production now using it. So it's, you know, like that. Yeah.
How do you deal with the local storage limits? I assume that 5 megs or whatever. It's
yes.
For the couple of JSON objects.
No, not that. Actually, when we counted it, 5 megs was really a lot. What is sent to the client is only data for the doctor that is logged in. So technically, I don't remember if I counted, but I think it was like, it needed to be like over 1,000 of patients with some visits, you know, diagnosis. It's really a lot for this type. We didn't store any binary data in local storage, just the hash. So even there's no local storage limit, like a check, for example. If someone would really reach that limit, it will crash. So yeah, but the thing is that it's very unlikely that in this application someone will reach that.
Yeah, practically I understand.
Yeah.
Typing 1,000 people offline all takes time.
Yeah, if you log in 2,000 doctors here in this machine, then maybe, but the question is whether 2,000 doctors uses one laptop.
I'm thinking like if you run these applications somewhere in the field in Africa, village, you have an iPad, there is zero connection.
Yeah, and you like 200 doctors in one hospital uses one iPad. Yeah, yeah, it might be a problem. I don't know, but yeah. Okay. So yeah, so as I said, if you are yeah, so thank you. So if you're interested in that technology, really follow me and contact me. I'm really open and for discussion and passionate about this. So thank you.